Hello everyone, welcome to another video. Today we're going to talk about the link register. Now the link register is an important register and there's a reason why it exists. In this video I'm going to go over two scenarios. The first scenario is not going to use the link register and we will see why there's a problem in our flow of instructions in our code and why then there is a need to use the link register to control the flow of instructions. So let's look at the first set of code that I have here to understand what's really happening. Notice, and I'll go into the debugger. Let me just build this and head it right into the debug window, and we have the disassembly window here. We are waiting on the first instruction, which is moving 1 into register 1, right? So we've got a bunch of basically move instructions, a couple of move instructions. These are basically um, these could be any instructions that you might want to set up, but the idea here is after you have these move instructions, you branch into a function, right? I've got an add function, could be any function in your case, but then you move into this function and you perform um, some basic code or anything of the sort. I'm just adding R1 and R2 and storing the result in the R3 destination register. But the question here is, once you've performed whatever you wanted to do in the add function, the flow of the code here is expecting you to move to line 8 and 9, which is then a bunch of move instructions again. And then you stop, right? And you indefinitely get stuck in the stop function right here, right? You keep branching with it. So the flow, understand the flow of the instructions here is a bunch of move instructions. You go into a specific function, perform some instructions there, and then you come back from the function to perform a bunch of other instructions. And then you end the code with the indefinite branch with the stop function, right? So that's the structure. That's the structure. But what's really happening here is if we step line by line, is after we have moved, 1 and 2 in registers 1 and 2, what really happens is, yes, we go into the add function and we go there and we perform the addition, but notice we never really come back from the add function to line 8. That's something we wanted to do, right? Because that was the flow, or that was the intended flow of our code. So we wanted to come back from the add function and move 4 in R4 and 5 in R5, but we couldn't really do that because once we got into the add function, the sequential instruction after line 12 was really line 13, and then that's where we got stuck again and again, right? So notice there's no mechanism, and this is the problem we're trying to solve. There is no mechanism to come back from a function and then continue doing what we were doing in our original sequence of instructions. So let me summarize the problem one more time. We had a few instructions in 5 and 6, line 5 and 6, and then we went to a function in line 7 and we did this is just one instruction. We could do a bunch of instructions here, right? So basically we went to add function and then we performed an instruction rest. We implemented that, executed that, but then after doing the things in our function that we wanted to do, we wanted to come back to the original flow of the program and then move 4 in R4, 5 in R5, right? We wanted line 8 and 9 to be executed. That's the problem. These are not getting executed. We don't have anything in R8 and R9, right? So this is the problem, and this is something that we want to solve. Now, to facilitate this, or to actually come back from the function and be able to continue doing what we originally intended to do, for this reason, we make use of what's called as the link register. Now, this is a specific register, which is R14, right? I'm going to go ahead and change this code. I have another code copied up, but there are two small changes, and I will go over the changes with you, right? So notice it's the same code, it's the same move and addition functions and everything, but there are two very important changes that we have done. Let me build it and go into the debug window, right? So there are two very important changes that we've done here. Notice we're not just unconditionally branching to the add function, we're using the BL command here, which is branch with link, right? So branch with link command lets us go into the add function, but then it also creates a link to actually come back from the function right here, and we could continue following the original sequence of instructions. The other change that's here is that after doing whatever we wanted to do in our function, we use the bxlr command, right? So this is branch indirect. The X here stands for indirect. So branch indirect to the link register LR, right? It's register 14 LR. So this lets us come back from the function to the next instruction that's supposed to be executed that we originally intended to execute, after doing whatever we wanted to do in the function. So this lets us come back to line 8 and then they get executed. Let's see if this is really happening. Okay, so let's go line by line. Yes, we did our move instructions. Now we go into the add function or whichever function this is. This is just an example. We do the addition. Yes, we have 1 and 2 added and we've got 3. But then the BXLR takes us back to line 8 and we execute line 8 and 9, and then we get indefinitely stuck in the stop function, and that's fine, that's okay. But notice in this case now line 8 and line 9 get executed thanks to the link register and its functionality. It lets us branch with a link, and then there's a specific mechanism to come back from the function and continue executing from where that link was established, right? We can execute line 8 and 9 this way. But I'm going to go over this one more time, but this time I also want you to notice what's actually getting stored in the link register in R14, right? So let's iterate one by one. We've got our move instructions out of the way. We now notice the address in program counter is 384, and that's the instruction, right? 384. We are branching with link to this function, and we head into the addition, right? We're right into the function. It's also important to note here that there's something that got stored at this point, right at this point, and that is 389 in the link register. So the link register stored 389 right away. And why is this a very specific and a very important number is something that we need to develop some understanding on, and I will come to it after just 2 instructions. Let me come back from this function. So bxlr lets me get out of the function and back to the original sequence, which is line 8, and I'm going to stop here on line 8. Now notice what is the address for this specific move instruction. The address for this is 388, right? And that is the address we have in link register. So essentially the link register is storing the address of the next instruction that needs to be executed once we come back from the branch and link function right here. Once we come back from this instruction, execution of this function, once we come back, this address that's stored in the link register is essentially the address of the next instruction. Now I know my eyesight is weak, and I can see there's a difference. The instruction is 388, but link register is storing 389. There's a difference in the least significant bit. The first bit is set to 1, and this happens because it signifies that we are in thumb mode. If you look at program status registers, we are essentially in thumb mode, and this is something we will cover in another video. But as of now, these are instruction set architecture modes that the processor can be in. It can be in ARM state ARM mode or in thumb mode, and those essentially tell you whether we are following a 16-bit or a 32-bit. instruction set architecture, right? So currently we are in thumb mode, so that makes our first bit set to 1. So the next instruction is 388, but when that first bit is set to 1, it becomes 389, right? So well, and the processor understands this. So when we come back from the function's instructions, it executes the 388 line. So we don't really need to worry about the difference. Yes, it stores 389 in the link register, keeps track of the state of the processor, but notice the instruction address is exactly the same that is for line 8, moving 4 in register R4. So that address is in fact correct, right? So it is 388. So one more time, let me summarize this second scenario one more time. We've moved a bunch of instructions. We've gone into a specific function, performed whatever we wanted to do. We've used the branch indirect command to the link register LR to allow us to come back and continue executing the original sequence of instructions, right? So we then execute line 8 and line 9, and then this is going to indefinitely get stuck in the stop function. Importantly, the link register is the one that stores the address of the next instruction that has to be executed after you have gone into a function, right? And we do this by using the branch and link command. Branch and link command, the BL command, right? This is different from just the branch unconditional B branching that we saw in the first scenario. Here we're using branch and link to go into the function, and then once we've done whatever we wanted to do in the function, we use a branch indirect to the link register to come back to our instruction. How do we come back to the instruction? The link register stores the address of this instruction. Notice this address is stored right at the time you branch and link. I can do this one more time. So after moving here at this point, the link register has all ones, but at this point, when you go into the function, the link register is going to keep a track of this instruction's address, right? So the next instruction is 388, but we're not going to 388. We're going to the instruction line 12, but the link register is going to remember that you have to come back to 388, right? Because we used BL command here, branch and link. And at this point, 389, you see 389 being stored in the link register, right? So it kept a track of what we needed to execute once we come back from this function, which is the address of this instruction, line 8. And then we keep on doing whatever we need to do in the function, use BXLR to come back. I hope this makes sense. Happy to answer any questions in the comments. Thank you.